Welcome guys, today we will be talking about how were the first programs written. So we all know that the current setup, like if I take languages like Python or Lua, they are written in C. C was written in assembly. How was assembly written? So assembly was written using literal binary feeding into your computer, into the old computer. So there were some super intelligent people who wrote the binary and then feeded that binary into the computer either by using punch cards or either by literally turning on and off single bits, and that's how the assembly was written. That's how initial assembly was written. That's how the assembly for Apollo 11 was written. So I have the Apollo 11 assembly right here. I can show you. So Apollo 11's assembly, let's go. So if you go, suppose luminary module, so as you could see, these are assembly codes, and this assembly was made using binary. So you could see that the syntax highlighting isn't working because this assembly isn't meant for my computer. This was meant for Apollo 11's computer. So that's the thing, and today we are going to replicate that. So let's just go project slash, let's quickly make a directory called uh, manual binary. Let's go inside manual binary. Okay, so we can write this. What the way of doing is, what are we actually gonna do is we are going to make a binary in a higher level language like assembly and or C, and we are going to feed that binary into xxd, the output of that binary, and then feed the output of xxd into another binary. So seems good. So that's actually, instead of xxd we will be using hexstone. xxd is formats the things, but we don't want it to be formatted. So let's go with an assembly program. You could write this in C, but I'm not writing this in C because if I write this program in C, I have to include stdio.h, and that will make the size of binary super long, and I don't want that. I want a clean output, so I'm going to write it in assembly. So let's start with global start. First let's declare some section. So section data and section text. Let's go global start, and let's have start right here. So it's going to be a hello world program. So let's have a message or hello world. So it would be an ASCII Z string called hello world and /n. Let's have the message length as a byte because it's not long, so I'm not willing to give word or long to this. It will be the current address minus the message address, which will give me the size. So current address is denoted by dot. Subtracting the message address will give me the size of message. Let's start. So first we are going to move 1 into RAX. That means we are going for a write. Then we are going to move 1 into RDI. That means we're going to write to stud out and not to stud error or to stud in. Then we're going to move our message address into %RSI, so it's, and then we are going to move our message length into RDX. Then we're going to invoke a syscall, and then we're going to exit, so moving 60 into %RAX, and moving the return code 0 into %RSI, and syscalling again. Okay, so this is our hello world program right here. We can link this. First let us create an object file from main.s and let us link this. Now we can run it, and we got hello world program right here. Let's hex dump our hello world program. So hex dump main. As you could see, this is the binary of our main. It's still so long. Why? Because we are invoking syscalls, and the LD that I'm using will actually merge the things with syscall. So what happens is LD actually merges all of the code required for syscall into my code. What we could I also see is we could see the string inside our binary. So we got hello world as a string, main.o as a string, and these all are inside our binary. But we didn't actually made these strings. We only have a data section and a text section. So these extra strings are the strings that came with the libraries that were linked. So now let's get back to our motive. Hex dump main. Hex dump main into main.bin and /main.bin. Let's try this. Permission right, just go chmod main.bin, and let's run main.bin. Okay, so what happened actually? Command not found. Let's do this to test dot slash. Oh, actually I understood. These are the things that created problem. Cat main is a binary thing, so I could cat main and then do test, and I could run test. Permission just chmod, just go with test, and now run hello world. What we actually did is we basically took the binary of our program and we pumped that binary into a test. So it is as if we copy pasted this binary, which we can do, and we will try to do. So let's go here. This is the test binary, and obviously we are not able to see anything. Let's go and paste our text here. So this is text. Be aware, this is not binary. This will be translated as a text. But instead of hex dump, let me do something like xxt over it. Xxt main. So this is the binary. And what am I thinking is to escape these binaries, and as you could see, we have a representation of a program in terms of string right here. So this part actually will be quite similar to the output of cat command right here, this part. So if I output cat, you could see elf this thing, then at the rate and this thing. So if you go and check elf this thing, then at the rate and h, so this is the string representation of the binary right here. And we actually did what people did manually. So if we copy pasted the bytes, so what we can do actually is we could escape and paste bytes inside a program. So let me just quickly get the byte. Okay, so what I have done here is is that I have wrote a C++ program that actually opens a file and reads its data into a vector and then outputs it data. So what is the motivation? I could have just used cat. Well, the point is, I'm thinking to parse these bytes into escape sequences, so like hex 41 and so on and so forth, and actually put these escape sequences in a text file and then run that text file. I know it's a crazy idea, but I will be doing that. Okay, so there you go. I have added this thing that actually outputs the bytes in terms of hexadecimal. So as you could see, escape sequences. Now these bytes are majorly zero, only somewhere we see actual data. So like we could actually compress the data. That's a thing that we could do, but that's for another video. When we'll be implementing MongoDB BSON format, then we will be using that compression thing. So let's get back to work. So bin dump, and I will pipe this output to a text file. We could actually check that text file. It contains the escape sequences, and let us try to run this text file. So /text.txt chmod text.txt and /. Okay, so it says command not found. Okay, let me see what was the error. Okay, so this isn't working. There has to be some another way in which I can do it. So I got a new command. Let's go with this. Let's go /test. Bam! We freaking did it, man. We freaking did it. So now I'm outputting the content of /main into a test, and I could run the test and hello world program prints. Yes, we did it. It took so long, but we finally accomplished it. We wrote manual bytes of the program. So I could go bin dump. We wrote the manual bytes of a program. We escaped them, and then we wrote that escaped sequence into a test. Mind it that the test file contains the binary right here, and NeoVim actually shows those escape sequences as these things. It's so nice. So yeah, we accomplished what people did almost around 50-60 years ago, but it was fun. Thank you guys for watching. I'll be seeing you soon. Bye.